All right, guys, I enjoy that you're here. We still have like 39 people in this class, so I might get a bunch of emails today, I guess. I don't know if it was like take hump day off day. I'm not sure. I remember high school, we had senior day off.
Senior
I'm a senior.
You missed your day off, man. Anybody else wasn't here yesterday? Mercy, right? Okay. Trying to keep names straight. So this that's up on the overhead, I'll do another example of this because there's a problem in the homework like this. So let's do it. I want to do one more example just to show you how this kind of works. There's at least one problem in the homework. I think there's a few. So it'll tell you that you have a, let's say, a fifth degree polynomial. Hey! And it's got, there's people. All right. It's got roots of 7, 2, and 1. And this happens with multiplicity, let's say, 3. Ooh, that would be horrible, Jeff. Let's not make this start. Let's say if this one happens. Multiplicity 3. That's better. Okay. You'll see why in a minute. But it also tells you that the y-intercept is something. Let's say 0, 20. You guys all with me so far? So there's a couple problems. It tells you how, with the degree of the polynomial, the roots it has, along with multiplicity. So real quick, if it's a fifth degree polynomial, how many answers must it have? 5. I've got 7, 2, and 1, but why is it okay?
Because the 1 has a multiplicity of 3.
So the answers are 1, 1, 1, 2, 7. That's 5 numbers. Cool. So some of them could be repeats, but that's still, those are each an answer. Yeah. Are you guys with me so far? Okay. So tell me, where would a root or a 0, so another name for roots is zeros, another name for zeros, you can put an E or not, another name for zeros is x-intercept. They all mean the same thing. So where would 7 come from? So again, x minus 7, 11. Where would 2 come from? And where would 1 come from?
X plus 1. No, X minus 1.
And it's got to be multiplicity 3, right? Good. Let's do the third time. Kick ass. Now, I left a little room here. I should have warned you, but if you didn't know. Because at the moment, what would the y-intercept of this be? What I've written so far. If I see if that's the answer, let's see. I'm supposed to have a y-intercept of 20, right? 0, 20. What y-intercept do I currently have?
0.
How do I figure out the y-intercept? How do I always figure out the y-intercept? Set x to 0. So that would effectively just mean multiply the numbers, correct? Negative 7 times negative 2. 14 times negative 1.
Negative 14.
Negative 14. Good. So is this the answer? No. It doesn't do one thing. It does everything else fine. It just doesn't do that one thing. It doesn't make the intercept 0, 20, right? The concrete way to do this is to say there's a number here, I don't know what it is. So I just pick a letter to represent. Of course, we're freaking past algebra, so we understand if there's something I don't know, I just call it a letter and do stuff, and hopefully I'll figure it out. So when I plug a 0 in, I'm going to get a times -7 times -2 times -1. And that is supposed to be 20, right? So I get -14a equals 20. So can you figure out what a is?
20 over -14?
Yeah, a is 20 over -14, or
10 over 7?
-10 over 7. Yeah. So that's what you would put right there, and then you would be done. Now, real quick, just to tell you. So that's a beautiful way to do it. It's nice and concrete. You don't have to kind of like guess or work in your head. Another way to do this is to say, okay, right now I have -14. It's supposed to be 20. So the number here could be divided by 14 to get rid of the 14, -14, and then multiplied by 20. I'll still get 20 over -14, but that's more of a way to do it in your head. I think this is the way the book has some examples. They do it this way, where they put a number here. Are you guys with me? Is everybody really cool with these? Where the hell these came from? Okay. That's the most important part, really. The minors are just a little extra calculation step. Okay. All right. Anything else from homework stuff? Anybody that wasn't here yesterday? Oh, okay. I love you so much. Let me grab you a. All right, come on down here. Yeah. Sure. Everybody else good? By the way, if you just got your test back, there's a, if I remember correctly, there's a test grade next to your name. There's 2 other numbers. Are there 2 other numbers next to where it says show your work up in the corner? On your test. Yeah. Not yet. That's right. I haven't done that yet. That's right. By the way, I'm sorry. Forget everything I just said. I was hoping to get the grade sheet summary done, but there just wasn't time. There wasn't time. Let me see real quick. Jeanette? Yeah. So I graded the corrections at least. Lena's not here. Lynn, Aaron, Raul is not here. Brianna, Dahlia, and an unknown person. Okay. All right, guys. Any questions before I launch back into where we left off? Okay. So very quickly, I was talking to one of my classes the other day. What do you guys do? Does anyone beyond tutoring, which is a great idea? So I know some of you guys go in for tutoring. It's really good. I also know that some of us don't have all the time in the world. Like when I was a student, even if they had tutoring, I wouldn't have been able to do it because I was just working 3 jobs. Holy shit. But also, has anybody ever found like a YouTube channel that's got pretty good videos explaining things? One thing you could, Khan Academy is a good go-to, right? After a while, his voice can get a little, whatever works.
Organic chemistry tutor, he has like a video on like everything.
Oh yeah, yeah, I remember this. Yeah, he tutors organic chemistry, but he just branched out.
He just does everything. Yeah,
yeah,
it's insane.
So what you could do is you could go to YouTube and just type in dividing polynomials. Just watch a few videos. You're going to see a lot of crap, and then you're going to find somebody who you're like, I like this, and then you're going to go to their channel, and you're going to see what else they got. You never know. Are you guys kind of with me? Excellent. So again, reading the book and come into lecture, 2 really good things. I have a certain perspective of mathematics that I deliver, and I do try to explain things in a different way when somebody says, I don't understand what the hell you just said. But I'm still one human. I have one perspective that I can kind of alter. So it's a really good idea. So when I was in college, grad school, I was lucky a little bit because I was good friends with some teachers. They would let me borrow some textbooks. So I had multiple textbooks for the same class because sometimes one textbook explains something really well, and the next thing is a little shit. So you go to another textbook, like, oh good, they explained that pretty well. You guys kind of with me? We didn't have the YouTubes at that time yet on the internet. It didn't exist. Yeah, way back when. How did we survive? Do you guys know about, there's something called Shams? It still exists. I looked it up. Here, let me write it up. There's a study guide series made by a company called, let me see, I don't know if you can see this, hold on. Shams. And it's really good for, they'll have a deep explanation of an idea followed by several problems with solutions. Do you understand what I'm saying? So they definitely have Shams study guides for pre-calculus, right? You guys kind of with me? There was another one, so Shams and this other one, REA. I'm not sure if these guys are going to have, they might, but REA normally has like higher level shit. And what REA is just this giant book of problems and then solutions. It's insane. So between those two, plus study groups, that's what got me through grad school, for example. I know you're not in grad school. It also helped in college, right? Whatever the hell topic I'm having trouble with, those three things, study guides, study groups, and now YouTube videos, right? Plus my office hours, unless you're really sick of listening to me talk and then you just go somewhere else to some other person. You guys kind of with me? Again, right now is a great time to realize I am not doing as much as I can. If you think you're doing everything you can and you're still making a low grade, come see me. We'll analyze what's going on. Those are the worst situations, trust me. 176, real quick, sorry, quick. You guys all know we're not allowed to teach intermediate algebra. Did I tell you about that? You guys know this? We used to have a course called Math 110, which was basically like college level algebra 2 that you could take before you took pre-calculus. Do you guys know this? We're not allowed to teach that anymore. This is not a joke. It is illegal for us to teach that in community college now. So if you're curious why, you can look up AB 705 and AB 1705, two bills that came from legislators who don't know math. There's a bit of a groundswell of students pushing back. I got the Student Government Association involved, and they've kind of like been doing task forces and stuff. All that's beside the point. So if you're sitting here thinking, man, it would have been great if I could have taken a refresher of algebra, all the math teachers agree. That would have been great, but we're not allowed to teach it. So you need to identify, do I need more help with prerequisite stuff, right? And if so, you got the tutors, you got me. Does this all make sense? Okay, I need you, right now, some of you guys need to grasp your own self and say, start doing this, right? This is the time. If you don't start doing it and you just continue, who knows, right? But you still have time right now. Even if you have a very low grade, there's still a lot of grades to be done. You can still make corrections, all this kind of stuff. And I still have people not get any points back on corrections. I don't understand that. So you could ask me if they look right, and I'll tell you what doesn't look right. You can go get help from tutors. Okay. I'll stop. I need you to understand, no matter where you are right now, you can still catch it and pull it back up. Okay. Hey. So, if you want to, these are good. You can get these from like Barnes & Noble, whatever. You can go on Amazon, of course. Everything in existence basically is on Amazon, so. Okay. Any questions from homework before I continue? A few more people came in. Okay. So kind of, I want to do a couple of synthetic division examples. Just to remind us, and then the next step is using synthetic division to factor things. So that's what we'll do after that. So help me out. Let's see. Let's see. Let me make a problem real quick. Always very exciting, I know. Let's see if this works. Yeah, okay, good. So look at this problem here. Okay, so I'm given this polynomial function. And I want to divide it by 3x plus 5. Now, can anyone identify immediately a problem if I want to use synthetic division? Yeah, the 3. So, do you guys remember there's two things that must be true to directly use synthetic division? Synthetic division is a shortcut to long division. What two things must be true?
The first coefficient has to be 1.
First coefficient has to be 1. First power. So it's got to be linear. It's got to be a first degree. You guys with me? So it's first degree. 3x plus 5 is first degree. Beautiful. I need to be able to use synthetic, but there's a stupid 3 in front. Damn it. So here's how you can do this. Let me see if you guys are cool with this. Isn't 3x plus 5 equal to 3 times x plus 5 thirds? You guys with me?
Yeah.
Doesn't this work? So if I'm dividing 3x cubed plus 14x squared, I could change this over. Give me a second, sorry. There we go. Plus 3x minus 20. I'm going to divide by 3x plus 5, but I'm going to write it like this. So what two things do I need to divide this by? What two things does this want me to divide by?
Divided by 3.
Divided by 3.
And x plus 5.
And x plus 5 thirds. So what I'm going to do is, I'm going to divide it by that. And then whatever I get, I'm going to divide each piece by 3. I'm going to do both, right? You guys kind of with me? One way to divide 80 by 10 is to divide it by 5 and then divide by 2. So you divide it by 10 total. Yeah?
Why is it 5 thirds?
Because I took a 3 out. So why is this in, if I take a 3 out, why is that an x?
Oh, because of the 3x.
Because I divided by 3. Yeah. Cool. So if I'm going to divide by this, what goes in the penalty box? And again, I just call it a penalty box. It's not officially. The little dude, what goes in the little room all by himself?
Minus.
Beautiful. The thing that makes this 0.
Oh, okay.
Sorry, I didn't mean to react so much. And then what goes up here? 3? 14? 3? I didn't need any zeros because I'm not missing any powers, right? Okay. Yes?
So you still put the 3 there even though you took it out?
Where did I put that 3?
With the 5 thirds?
So this 3 is not anywhere yet. It's right? All right, there's the negative 5 thirds. That came from this, correct?
Yes.
Good. And then this all came from the top, correct? So when I do this, I'm dividing by this. When I'm done dividing by that, I still have to divide by, what else do I have to divide by? 3. So whatever answer I get down here, I'm going to divide all that by 3. Does that make sense? Yeah, if I'm dividing by 2 and then I divide by 7, I actually just divided by 14. That's the idea that we're using. Okay. Now, I know this does not excite you. I don't blame you. Well, let's just hope. What's really nice that this 3, what gets me started? Bring the 3 down, right? And then what do? Multiply. Right? Negative 5/3 times 3 is beautiful. Yeah, negative 5. The 3's cancel, yes? When you do that, the 3's cancel. Are you guys with me? So I'm hoping I get multiples of 3. That would be so nice. So what's 14 minus 5? Holy shit. Okay. What's negative 5/3 times 9? 3 goes into 9. 3 times negative 5?
Negative 15.
Negative 15. You guys with me? The what now? Here? Okay. Negative 5/3 times 3. Here's a really cool way to think about this. If we're going to multiply by negative 5/3, what's the 3 actually going to do? It's on the bottom. What's the 3 going to do? Divide. And then I'm going to multiply by negative 5. So if I'm going to multiply by negative 5/3, I just think, here's the number. Divided by 3, multiply by negative 5. Bam. Here's the number. Divided by 3, multiply by negative 5, negative 15. Bam. So you can look at a fraction as 2 things you have to do. You have to divide by the bottom number, multiply by the top number. It's a beautiful way to do shit with fractions. Just look at it as 2 things I have to do. What's 3 minus 15? Thank the gods, because divide that by 3
Negative 4.
times negative 5,
20.
20.
0.
Why is that cool? Why do you love seeing a freaking 0 there?
Gives me evenly.
When in evenly. So what did we actually just do with the original polynomial? We just did what to it? We factored it. Kick ass. Now, not quite. There's one more step I've got to do. I haven't fully divided yet. I still got to divide by 3. I really want you guys to understand this. We just did this. We divided this by this. Bam. We still have to divide by 3. Well, that's awesome. By the way, let's do this first. What does this represent? 3x. How do I tell what the hell this is going to be? What was it? Yeah, it was to the 3rd power. I divided by an x. So, of course, now it's going to be the 2nd power.
Where did you get the negative 5?
Where? Which negative 5?
Under the 14.
Oh, okay. All right. Whatever number, when I bring it down, then I multiply, correct? What's negative 5/3 times 3? We'll divide it by 3, and then multiply by negative 5.
Okay.
Yeah. Divide it by 3, multiply by negative 5. Divide it by 3, multiply by negative 5.
Okay.
Yeah. You guys with me? So multiplying by fractions are not nearly as freaky as they look or they need to be. You guys at all with me? Look at a fraction as 2 things. I want you to divide by something, and then I want you to multiply by something. That's what every fraction says when I multiply by them. 3x squared plus 9x minus 12. So the actual answer is going to be those are all 3's, by the way. My 3's get really lazy. X squared plus 3x minus 4. So tell me, how do I factor 3x cubed plus 14x squared plus 3x minus 20? That was the original problem. How do I factor it? What does this mean?
Divide by 3, multiply by 5.
So actually this means 3x plus 5. That's where that came from, right? And then this would be x squared plus 3x minus 4. So if I was doing this problem, I actually would not do this step. Because what makes this 0 is negative 5/3. That's what goes here. You guys kind of with me? Okay, I like it. Now real quick, just side note here. Side note. When I did this, this was 3x squared plus 9x minus 12, right? Let me see. This is all side note. never do this shit. And I divided by 5, so this should be x plus 5/3, correct? I don't know if anybody out there is like, why didn't you write x plus 5/3, Jeff? Because what really happens is, if I take a factor of 3 out, I can then give that factor of 3 to this piece. That is really what happens. But you never have to write that shit. If you don't want to, you don't. Okay. Now, if you weren't here yesterday, none of this probably made sense to you. So that's why I got this little handout. And you can watch the video, of course. Right? So has everybody got this here? Yeah, this looks exciting. Once you do a few of these, you will really appreciate the hell out of this. That is much better. You don't have to, but I'm pretty sure you will. All right. Any questions about that? There's a few homework problems where you're dividing by something where the first coefficient is not 1. Right? And we've seen this already. Like completing the square is another situation that's built on the first number being a 1. So if it isn't, we got to do some weird shit. Right? Maybe. Yes.
Do you want us to write the original function equals to what we got?
Depends on the question.
Okay, so
If the question had said, find all the zeros of this. And by the way, I'm kind of happy you reminded me. Am I done factoring? No. But we do know 1 0 already. Can anyone tell me 1 0? 1 intercept, 1 root. Negative 5/3. Negative 5/3 worked. It went in evenly. It is a 0. It's a root. It's an x-intercept. Those are all the same thing. Are you guys with me so far? Every time synthetic division works, you found a root. You found a factor is another way to think of it too, right? Is this fully factored? So if the problem said fully factor this, why am I not done?
Because you haven't factored it.
Yeah, I haven't factored this yet. Is this factorable?
Yeah,
It is, totally. How do you factor this thing?
It's going to be x. Well, there's a
X plus
4
4.
and a 1.
And the bigger one's got to be positive, right? Now, so the problem said fully factor this. That's the answer, correct? And make sure you fully factor it, right? If the problem said what are all the zeros or the roots or the x-intercepts, that's not the answer, but now I can get the answer. I already knew one answer was negative 5/3, and that comes from this dude, right? So one answer would be, if the answer was factor, completely done. If the question was find the zeros, what's the 0 for this guy?
3 times x plus 5.
Well, it's negative 5/3. That's the one we already found, right? What's the 0 for this guy? Negative 4. What's the 0 for this? 1. There. You guys see what I'm saying? So it depends on the way they ask the question. If they say fully factor it, you don't have to find the zeros. If they say find the zeros, to find the zeros, one step might be factor, of course, right? Okay, so normally, if the question is find the zeros, you're going to have to factor anyway. Okay, so it's like one extra step is finding the zeros. Okay, how you guys feeling? Does anyone like synthetic better than the first time you saw it? Okay, all right. And again, this happens later this semester. We're going to do something really exciting called matrices. And that's another good example of the first couple times we do stuff, you're all going to really not like it. But then after we do a few, you're going to like, okay, this is kind of nice. We'll see if that's true. All right. You're all like, you've lied before, Jeff. Be quiet. All right, so the next thing I want to focus on is, let me see, I did print that out. That's awesome, Jeff. Let's see if you guys remember something we did the other day. And again, I should have, well, let's do an easy one first. Let me see. Yeah, let's just do this. So let's say I give you a polynomial, looks like this, x to the 5th minus 4x cubed plus 5x squared minus 7x plus 20. Now, trust me, I just came up with that out of nowhere. So I would put a lot of money that it's not factorable. But if they gave me a problem and they said, factor this, we don't have a method to factor that until what we did yesterday. I can use synthetic division to try to factor this. Are you guys with me now? Does everybody understand synthetic division? It's got broader implications, but one really good thing is it's a factoring tool, like we just did, right? Can anyone tell me what numbers would make sense to try to put in the little penalty box? What numbers would make sense to try in the little penalty box? Would it make sense to try 11?
No.
Would it make sense to try 2?
Yeah.
Why? Because it's a nice number. Would it make sense to try 3?
No.
No, it would not make any sense to try 3. Does anyone understand why?
Because you don't have any more.
Now watch this, guys. Guys, watch this. If I had something that was already factored, x minus 7, x plus 5, x minus 2, let's say, what would the last number be if I multiplied this stuff out? Blah, blah, blah. What's the number at the end? What would the number at the end be?
70?
70?
Yeah, negative 7 times 5 is negative 35 times negative 2 is positive 70. All right, guys, is that cool? You guys see that? I don't have to multiply it all. I don't have to foil just to figure out what the stupid last number is going to be. I don't. I know it's going to be multiplied. How do I know there's an x cubed out front? Because I multiply x times x times x. Now, if you had to multiply that shit out, you better foil and then do the last dude. You better do it step by step. But that's not the question. So this is 70. Do you understand then that these numbers at the end will be factors of the number at the end of the whole polynomial? Does that make sense?
Yeah.
So it would not make sense to try to use 11 to divide this because 11 doesn't go into 70 evenly. I'm hoping for nice whole number answers, right? Yeah, maybe. So, coming back up here. Can you make a list of numbers that would be smart to try?
Yeah,
1, because 1 goes into 20.
2,
2,
5,
4,
4,
5,
5,
10,
10,
and 20.
20. Now, real quick. That is half of the answers. That is half of the numbers.
all the negatives.
Plus or minus, yes. Okay. Is that a relatively big list, especially considering that you're going to have to check each one until you get something that works?
Big enough.
Wouldn't it be really easy for me to make that list even bigger? What if I put 60 at the end? Does that have a lot of factors?
Yeah.
Yeah. By the way, real quick, guys. I'm going to tell you a little side note. Let me see if you guys get this. Do you see how whenever you make a list of factors, I don't know if you've ever thought about this, you get to a point where you start pairing the next thing with something before. You guys see what I'm saying? You guys notice that? You get to a point where you're like, okay, now this goes with this. So if you knew where that point was, you could stop thinking at that point, because then you're just pairing shit up. Do you guys see what I'm saying? What's the square root of 20 roughly? It's less than what? Or more than what? It's between... Yeah, it's less than 5 because 20 is less than 25. You guys with me? And it's more than 4 because 20 is more than 16. Are you guys with me? So somewhere between 4 and 5 is going to be that turnaround point. If you don't understand what I just said, it's okay. I'm just telling you a little extra side note that would be really helpful. So real quick, if I had to, let's do another one. If I had this polynomial here, it doesn't even matter what the first stuff is. It really doesn't matter. Blah, 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 blah. Okay. Minus, what do you got, Jeff? 48. What's the square root of 48? Almost what? Square root of 49 is, so square root of 48, almost 7, correct? So watch this, watch this. If I'm going to make this list, there's always a 1 that could be, because 1 goes into any damn thing. What else goes into 48? Keep going. 2 goes, well, all right, let's do it in order. That's a good idea. Because I don't want to miss anybody, so you don't want to just do it randomly. 2, and then what's next? 3 goes in, yes? You guys with me? Okay. real quick little side note there. Did I tell you guys if you add the digits and they're a multiple of 3, then 3 goes in? 4 plus 8 is 12. That's a multiple of 3, so 3 goes in. What else goes in? 4. So remember, the square root of this was 7. So once I get to 7, that's when I can stop thinking. I'll show you what I mean. What else goes in? 6.
8.
Now I've got to 7 basically, right? So now I can just start pairing these off. 6 times 8, 4 times 12, 3 times
16.
2 times 24, 1 times 48, plus or minus, right? Do you guys see what I'm saying?
Yeah.
One thing you're going to have to do is make this list. So that little thing I just told you about taking the square root of the number you're looking at, it's stupid useful. I'm almost sure some of you guys have noticed you get to a point in making a list of factors that you just start to pair it with something that came before. It's always going to happen right around the square root of that number. It's kind of nifty. If you don't get what I mean, you can make a list of factors. You can do that. You've done it before. You can do it again. It's just going to be a little bit harder for you, right? Which is fine. Okay. Now, so the next step, if this was a real problem, is I would just pick a number and then start synthetically dividing. And if it didn't work, I would pick another number and start synthetically dividing. And if that didn't work, I would write it down. Okay. So, don't you wish, you wish a lot, don't you wish there was a way to cut down on the size of this list? I'm going to talk about several ways to cut down over the next couple classes. So, we'll do one today, hopefully. We'll see what time it is. There is a way. Sometimes there's a way to cut that list in half, which kicks a lot of ass. Cutting the list in half is awesome. It'll still be kind of long, but it's half as big as it was. So hey, you guys sit by with me. We will get there. Yes. So again, what does synthetic division? What's one thing it could help me to do with a polynomial? Factor. So we're trying to factor this. Why am I making a list of factors of 48? Because those are the numbers that it makes sense to try to put in the little box with factors. Is that cool? Because that's where 48 would have come from. If I had it in factored form, all the numbers at the end would multiply to 48. So these are all the possible things that could have been in there. Does that make sense? It's a really good question. In the middle of a derivation, you're like, what the shit are we, why are we doing this? Go ahead and ask them. Maybe don't ask it like that. But, okay. So, there was another thing I got into the other day. Yesterday. That is the other day. Where if the first number is not a 1. So just to remind you guys, we just saw an example of this right here. This one we did earlier. What would let's do this. All the possible roots we could try would have been 1, 2, 4, 5, 10, 20, right? Now real quick, what were the roots we ended up getting? Weren't they -4 and 1? And those are in this list, -4 and 1, yes? Okay, you with me? But what else did we get? -5 freaking thirds, right? Why do I get a fraction, Jeff? It's not my little list. Because this is not a complete list. The first number is not a 1. That always screws us up. So, the only way to get a fractional... So if I start putting together a polynomial function, if I start putting one together, have I got a fractional root yet? What's the only root I've got so far?
-5/3.
1.
This one right here. What's the only root that I know so far? 1. Do I have a fractional root yet? No. What do I have to put down so that I get a fractional root? Not a fraction, really.
Coefficient higher than
A
1.
multiple.
Do I have a fractional root now?
Yes.
And if I multiply this shit out, won't the 4 be in the front?
Yes.
Okay. What would the fractional root be?
5/4.
Do you see how this number's up top? This number's on the bottom.
Yes.
Do you see that? Okay. So what does that mean, Jeff?
Would it
Dear
not be
God?
-5/4?
Well, it'd be plus or minus.
Well,
Well, this is positive 5/4 because that's minus, yes?
Yeah.
But if I was making a list of possible roots, it would be plus or minus 5. Okay. So what that means is this. If I'm given a polynomial and it's got a freaking number out front, y'all bang it. Let's see. Yeah, sure. Okay. You guys all with me? I start off the same way we did earlier. So if I want to make a list of all the possible rational roots, let me put this down. Possible rational roots. Start off the same way we did before. What are the ones for 6? So plus or minus. Make a list of factors of 6. 1, 2, 3, 6. Right? You guys with me? Square root of 6 is 2. That's the turnaround point. 2 times 3, 1 times 6. So don't forget, 1 is always 1, and the other one's always the number itself. I am then, remember, where was the stupid 4 that was in front? Did it end up on the bottom? So what number, I got a stupid 4. Damn it. I got to divide this by plus or minus 1, 2, 4, all the factors of 4. Now this is where you're really going to, if you hated me before, you're going to find new depths of hatred for me. And then we're all going to be a little bit better when I show you how to make the list smaller. Now, what the shit does all this mean, Jeff? Well, I've got to make every ratio possible. What do I mean? If I divide each of these by 1, I just get them. Is that cool? Then I get 1 divided by 2. 2 divided by 2 is 1. I've already listed it. 3 divided by 2 is a new one. 6 divided by 2 is 3. I've already listed it. Then I divide by 4. 1/4 is a new one. 2/4 is 1/2. I've already got it listed. 3/4 is a new one. 6/4 is 3/2, and I've already listed it. You've got to make all the ratios. So these are all the possible numbers that could show up at the end of each factor. Same thing we've been doing, except now when there's a stupid number out front, we know it's going to end up on the bottom when I solve to get to 0, so that's exactly how we cover our ass for that possibility. We put them on the bottom. So, let me give you this. Yeah, I'll do this right now, even though it's got more on here than I want. It's on the other side of this. Oh yeah, good. I just want us to look at number 1 on this for the moment. Just looking at number 1. Don't worry about whoever the person is in number 2. Go ahead and do 1A. Oh, wait. Still going, yeah. Missed. See Stephanie. Oh, Elena. Landon, Aaron, Raul, Brianna, Dahlia. Hey! All right, let me catch up to you. This was nifty. What's the square root of 36?
6.
So that's nice when it's an actual number. You know, when you get to 6, that's when you turn around. So let's do it. 1, 2, 3, 4, 6. Now I can turn around. 9, 12, 18, 36. Okay. Do you see how that's useful? If you don't, okay, good. If you don't need it, you've done it before, you can make a list. But it's just a little useful to know when the hell it's going to turn around like that. Why do I not have to divide by that by anything? I kind of do, to be honest, but what's the first number? What's the first coefficient? 1. So if I divide by 1, it's all the same, correct? So I actually do always divide by the factors of the first number, but when it's a 1, it ends up not changing, right? Not introducing anything new. So part B should not be horrible, but notice it does have a 2 out front, so try to make the list for part B. This number kicks a lot of ass. This is not linear vectors. We'll see if you guys agree. So what goes on the top?
1 and 2.
1 and 2. What goes on the bottom? 1 and 2. Then you make the ratios, right? So 1 divided by 1, 2 divided by 1, 1 divided by 2, 2 divided by 2 I already have. So the best situation when you have a number out front is that the last number doesn't have a lot of factors. Then even though you have fractions, they're not a lot. You guys semi with me? And then, of course, the next thing we're going to do is we're actually going to use these numbers to try to synthetically. And the next thing we would do is these are all the things I would guess to go into the little penalty box. And then I try to synthetically divide until I get a 0. Okay. Do part C. I'll stand up here. Oh, I'm going to start to catch up to you. What goes on the top here? Cool. It's always nice to get a number with not too many factors. What about the bottom? Oh, shit.
1, 2, 3, 4, 6, 12.
Okay. So now you got to make all the possible ratios. So you always get these numbers because they divide by 1. Then I get 1/2, 3/2, 9/2. So everybody with me? You're just going to make all the possible ratios you can. 1/3. 3/3 is 1. I've already got that down here. 9/3 is 3. I already got that down here. 1/4. 3/4 is new. 9/4 is new. 1/6 is new. 3/6 is 1/2 I've got already. 9/6 is 3/2 I've got already. Is this cool? Or not cool, but understood. 1/12. 3/12 is 1/4. I've got that. 9/12 is 3/4. I've got that. Look at that list. Oh, yeah. Oh, shit. So, that's a skill by itself. just figuring out all the things that you would then have to go try to synthetically divide by and hope to God to get a 0 quick, right? That list is big. So let's talk about what number 2 says. You can't do number 2 yet because we haven't talked about it, but do you guys know the name of the XY plane? You guys know the official name for the XY plane? Starts with a C. Oh, okay, coordinate system. It is a type of coordinate system. We're going to learn another one later this semester. That sounds great. Cartesian. So it's named after this guy, Descarte. Right? So the urban legend is he was sick, looking at a ceiling, watching a fly walk around. He's like, I could identify where that fly is with these set of axes. And math has got a lot of boring urban legends. We'll never make a movie out of it. I'm sorry. Did somebody have a question?
Yeah, would there be more factors than that? Oh no, I'm just not reading part of it. Never mind.
That's okay. Yeah, when you get some that repeats, you don't have to write them again. Yeah. Now, just to let you know who the hell this Descartes dude is, right? René Descartes. So what René Descartes figured out about these things? Let me show you an example. So let's say I have. Can you guys see? See if you guys are cool with this. What does it mean for a number to be a root of this? Or an x-intercept, or a 0? What does it mean? So if 3 was a root of this, what would that mean? What does 3 do if I plug it in?
Evenly backwards?
No. Not if I divide by it. If I plug 3 in. If 3 is an x-intercept, and you all know this, what happens at the x-intercept? Every x-intercept, what's the output? Give me an x-intercept. Yeah, it's 0, right? So if 3 worked, it would make this 0. Are you guys with me? Can anyone see why in the hell a positive number would never make this 0? Can anyone see why a positive number could never make this 0?
Because we can't add something to a positive number.
There you go. If I put a positive number in, the only way it could equal 0 is if I can cancel some stuff out. But wouldn't every single term be positive? If I put a positive number in, every term's positive. How could it ever equal 0? Do you guys see that? Do you see that? Okay. All right. So this one piece he figured out is if all the signs are the same, that list we've been making with the plus or minus, if it was this problem, I don't even have to consider the pluses. There's no way a positive number is going to be a root of this. Do you guys see that? There's no way a positive number could ever make this come out to be 0. If that was a minus 11, could it work? Could there be a number that would make it 0? Yeah, because this shit is positive, yes? If I put a plus in here, isn't all this shit positive? If that was minus 11, it could be 0.
So if it was all negative, then it couldn't be positive. Or it couldn't be negative. It would only be positive, right?
Hold on. All right, we'll get there. Okay. So one thing René Descartes. One thing he said was, if you see no sign changes, that means there's no positive roots. For exactly the reason we just talked about. If I put a positive number in, there's no way in hell it's going to come out to 0. In fact, can anyone tell me what is the smallest output I could possibly get for any positive input? I love that question. Of course you would, Jeff. 11, exactly. The smallest output I could possibly get is 11. And that's when I put a 0 in for x. Anything else, any other positive number is going to be bigger than 11 because it's going to add some shit to 11. Now, could a negative number make this 0? If I put a negative number in there, could it be 0? Hell yeah. 4x squared is always going to be positive, correct? But x cubed and 7x, they would be negative. Then could stuff cancel then? So the only way things could be 0 is if shit can cancel. And the way it is now, if I put a positive number in, ain't nothing going to cancel. Is that right? Okay. So Descartes, it's called Descartes' rule of signs, because you just see how many sign changes. The one time that it's helpful is when there are, in certain situations. In this situation, it kicks ass. It cuts my list in half. And that's good because the list is all the numbers I've got to try. And if I can cut down on that, shit, yeah. I don't have to try as much. Okay. So, let me ask you this here. Get out. What if I put a negative number in? What happens to this? Yeah, let's see if you guys are cool with this. Let me just go ahead and do it, and then I'll show you a shortcut for this. Every odd power, is it going to kill the negative? Nope. Every even power, kill the negative. So the shortcut is, you just change the sign of all the odd power stuff and keep the sign of the even stuff positive. Same sign. And of course 11 didn't give a shit what x is, because it's just 11. So if I put a negative number in, is it possible for there to be things that make this 0? Yes, because now some stuff could cancel with each other, right? In fact, how many sign changes do we see? 1, 2, 3. So there could be 3 negative real roots. So that's the big thing that Descartes figured out. The number of sign changes that I see is equal to the number of either positive or negative. So how many positive roots could this have? None. Because there were no sign changes. How do I investigate negative roots? I put a negative x in. It could have 3. 1, 2, 3. Now, let's see if you guys are really cool with this. Do you remember the problem, like if I put this in the calculator and it had 1 real root? How many complex roots must it have? How many roots should it have total?
1.
What's the highest power in there? 3. So how many roots should it have total? So it's called the fundamental theorem of algebra. We've talked about this before. The highest power I see is the number of roots I should get. We just did an earlier example with they tell me the roots and I can put it together in the multiplicity and so forth, and we compare to see if I get the right number of answers. Yeah. So I should get 3 answers. Okay. I really need you to understand this. So let's do a simple example of what I'm about to talk about. How would you guys solve this? How many answers should there be?
3.
How many answers should there be? 3. Yes. How many real answers can you see? 1. 2 works, yes? But we're better than that shit now. We know there's supposed to be 3 frickin' answers, right? One of them's real, the other 2, no. So how would I solve this to get those other 2 answers? You wouldn't add 8. How do I solve a problem like we're getting? No, with higher powers than 1? Don't I factor it? How do you factor this? How do you factor this? Yeah, XXX, 222. X minus 2. X squared. So what's the middle sign going to be? Plus 2x. Okay. Equals 0, right? So either x minus 2 is 0, and that's where we get 2. I did half of it. Or x squared plus 2x plus 4 equals 0. And what would you do to solve this? Can you factor this?
You can't ever factor the big guy.
Exactly. Thank you, Michael. You can never factor the big guy. So this is not going to factor. So what do we use? Anytime I can't factor a quadratic?
Use the quadratic formula.
Yeah. So it'll be x equals
Minus b.
negative 2, negative b, yeah, plus or minus, square root of 2 squared minus 4 times a times c, good, all over 2a. I like that. Somebody set an alarm hoping I would shut up. My time, I got more time. What do I get inside here? 4 minus 16, which is negative 12. So what kind of answers is that? What kind of answers are those? What do I do? Square root of negative 1. I. And of course 12 you can break up and I don't care at the moment. All I care about is the fact that I got complex answers. What's the only place, given any of the polynomials we've ever seen in this class, what's the only place I can get complex answers is when I do this quadratic formula, right? That's the only place. And how many answers does it always give me if it's complex? How many answers does it always give me? 2. So let me make a statement. Given a polynomial, nice polynomial, nothing freaky. If it has complex answers, they must show up in pairs. What's the opposite of a complex? Not opposite, but what's the other kind of number? Complex number? Real number. Okay, good. Right? So if it's not real, it must be complex. Does that make sense? Sort of like a parabola that doesn't quite reach the x-intercept at the x-axis, right? It's got 2 complex answers, right? Okay, no real answers. Okay. So coming back to our problem here. It could have 3 negative real roots. Or, yeah?
So, you put it in the quadratic formula minus
The answers, yeah. What does quadratic formula do for us? It solves x squared something equals 0. That's its fundamental purpose. Right? It doesn't pass the butter, it solves that. Say again?
This would be the final answer, negative 2 square root of 12.
Yeah, the roots would be 2 and these 2. That would be the answer to this equation. You guys semi with me? So everybody in here knows one answer was 2, yes? But it only shows up once. And there should be 2 other answers, yes? Because it's got a power of 3. The other 2 answers are the ones we don't even think about until now. They're the complex. So tell me, since complex numbers must come from a quadratic formula like this, and I'm always going to get 2 of them, yes? If I don't have 3 real roots, that must mean 2 of them were complex. So it's either 3 or 1. Negative real root. Because if it's not real, it must be complex. And how many complex will I always get if there's any? Pairs of them. So I could get 2 complex roots. I could get 4 complex roots. I could get 6 complex roots. I cannot get 3. I cannot get 1. So I need you. So if I count the number of sign changes, that is the number of roots, real roots I could get. And then I got to take that down by 2 to cover my ass for maybe there's some complex answers. Okay, I like it. Some of you guys look like you remember. Yes?
So this would count as 2 complex answers?
Of course. Can somebody please again remind me why I know there are 2 numbers here? This is 2 numbers, yes? There's negative 2 plus this and negative 2 minus this.
Okay.
The plus or minus, 2 answers. Right? Okay. I like it. Okay. So, coming back to this. Where'd it go? Where did I put them? Here we go. That's them. I got so many papers. Blump, blump, blump. Somewhere there is mine. Is it down here? Yes. Okay, John. Good job. Coming back to this. Okay. This problem right here. How many positive roots can there be? Do you see any sign changes?
No positive roots.
So there's no positive real roots. How do you check to see how many negative roots there are?
Put in a negative X.
Put in a negative x. What's the shortcut? All the odd terms, odd power terms, are going to change sign. You guys cool? I don't have to put a negative x in. I can just realize the square is going to kill the negative. The cube in the first power is not. So this will be negative x cubed. This stays positive. This becomes negative. And of course, 36 doesn't give a shit what I do with x. Right? It's just 36. That is just a shortcut, so I don't have to put negative x in. An odd power is going to keep the negative. An even power is going to eat it up. How many sign changes do I see there? 1, 2, 3. So as I move through the terms, how often does the sign change? What was the original sign? What's here? That's a negative. Did it change sign?
Yeah.
Okay. Sorry? No. It's negative here, yes? If I move, do I see now a new sign, a different sign? A positive, yes? Isn't that a positive? Okay, so that's negative. Did the sign change to the next term? Yes. Did the sign change to the next term? Yes. Did the sign change to the next term? Yes. So I see 3 sign changes. So there could be 3 negative real roots or
Lower. Smaller. Less.
1. Why do I go down by 2? Because if it isn't real, it's complex. And complex always shows up in pairs. Yes?
So if it was negative 10, would it be 4 changes or still 3?
No. All right, so if this had been negative x cubed minus 10x squared, you mean? Like this? Like that?
Sure, yeah.
How many sign changes? Did the sign change? Nope. Did the sign change? Did the sign change? Yes, 1. So there would have been a 1 negative real root, yeah.
So it's just based on how many...
Sign changes. As you move from term to term, does the sign change?
Okay.
Yeah. Okay. And that really fundamentally is related to, if there are no sign changes, then there can't be any of those roots. So when you start having sign changes, that allows for cancellations to happen. That's the whole idea. Yes?
Can you just explain where the or 1 came from again?
This?
Yeah.
Okay. This is 3 real negative roots, right?
Yeah.
If it isn't real, it's complex. And how do complex numbers show up as solutions? They show up in pairs. So I can either have 3 negative real roots, or if some are complex, they got to show up in pairs. Or I have 1 negative real root with 2 complex roots. Yes? So it's either, I've got to have 3. I've got to have 3. Do you all agree with me? Because it's a cube. So it could either be 3 negative real roots, or it could be 1 negative real root with 2 complex roots. It's got to make 3 total. All right, let's look at B. So if you just leave it alone, you can tell, looking at the signs, you can tell how many positive roots you're going to get. So what do we see? First thing is positive. So how many sign changes do I see? Let's see, let's count. Here's 1 sign change, yes? There's 2 sign changes, 3. From term to term, how often did the sign change? 3 times. So how many positive real roots could there be? 3 or 1 positive real root. How do I check negative real roots? P of, yeah, put a negative in. All the odd is going to change signs. All the even is going to stay the same sign. How many sign changes do I see now? Two. So there could be 2 or 0, negative, real roots. So really quickly, just looking ahead a little bit. If you do Descartes and you'll see this, and I got a big list of numbers that I have to try, I'm going to try the positive runs because I'm guaranteed that there is at least one that works. Do you see what I'm saying? There could be none of the negative ones might work. But I'm guaranteed that one of the positive ones will work. And of course, we still have to do some examples, so that makes more sense. But I just want to point out the utility of this. Descartes either helps me out like a stupid amount. It could cut my list in half, or it does barely anything for me. That's the reality. So sometimes Descartes' rule of signs is shit. It doesn't help me. But, on those cases when it does, it kicks a lot of ass. Okay. So what about this last dude real quick?
One negative real root?
Let's see, so there's, be careful now, if I leave it alone, that tells me which kind of root. So I got 1,
Negative root.
nope, positive, real root. Now real quick, why don't I go down by 2? Because I freaking can't, right? So you always stop when you get to 1, because you can't take 2 away from 1 and make any sense. Does it make sense? When we're talking about number of things, yes. How do I check the negative roots? Well, I put a negative x in. Does everybody understand the shortcut I'm doing?
Yes.
When I put a negative in, the odd powers are going to change sign. The even power terms are going to stay the same sign.
Okay, so why is it one positive real root?
How many sign changes did you see in the original polynomial? 1. There you go. That's it. That's why. The number of roots is related to the number of sign changes. And again, why does that make sense on some level? If there's some positive, some negative, that means they could cancel. The more of that there is leads to more possible answers. That's what Descartes kind of put together. What about this one? How many sign changes do we see?
2.
Yeah, we see 1, 2. So there could be 2 or 0 negative real roots. So again, from a practical standpoint, I would try the positive ones because I'm guaranteed one of them works. None of the negatives might work. There might be some complex in there, right? So on a problem, we would do both this. We would do this first, right? We didn't do that for these because we weren't worried about it. We would make a list of all the possible real roots, and then we would see if Descartes helps me. On this one, what would kick a lot of ass is I wouldn't have to put plus or minus factors of 36. I could just put negative, because there's no positive roots. That cuts my list in half. And I want my list to be small, because that's all the shit I got to put in and try. Yes?
So this doesn't include the complex numbers?
Yeah, complex numbers, I can't possibly guess ahead of time what they're going to be.
Oh, it's still possible.
Oh, hell yeah.
Okay.
Yeah. Okay. Okay. So, yeah, next time, we're basically out of time. Next time, we'll do this other side, which is everything. I've got one more idea to discuss with you that the book actually doesn't even tell you, but it's really freaking useful. So we'll talk about that next time. If you just got here, here's a copy of this thing. Oh, and I thought I had something. No, I guess not. Okay. What's up? Yeah, that's what we're just working on.
How quick you put up your class on the online?
Normally they'll be up by early afternoon. Yeah, but sometimes technical difficulties, so they should be up. Yeah, should be up by this afternoon. Oh, I give you the formula already. would open down. So where would the maximum? What's the name for this? Vertex. Do we have a shortcut to find the vertex? Okay.
What's that short?
Oh, Jesus. 5, 5?